All right, what we're going to do now is I'm going to show you how to graph a quadratic if you're given a quadratic function. Now, the difference between just an expression and a function is this. A function includes two variables, not just one variable. See, if we look up here, we have y equals 2x squared minus 8x plus 6. Now, if it was just, hey, I've got this expression, 2x squared minus 8x plus 6, that is just a quadratic expression. If I have 2x squared minus 8x plus 6 equals 19, that is an equation with a solution, or presumably it has a solution. It may not have any solution at all. But when we put in front of the quadratic expression, when we put y equals, now we have two variables. And the idea here is this, is that if you were to put some value of x, some value in for x, you would get a value for y. And there are an infinite number of possibilities. If I put a 1 in for x, 1 squared is 1, times 2 is 2, 8 times 1 is 8, so 2 minus 8 is negative 6, plus 6 is 0. But if I put a different number in, like let's say 5 squared is 25, times 2 is 50, 8 times 5 is 40, 50 minus 40 is 10, plus 6 is 16. And so depending on what value I have for x, I'll have a different value for y. That's the definition of a function. That for each value of x, there's only one value of y, but if I change x, I could get a different value of y. So it's a relationship between where there are an infinite number of possibilities. Depending on the x, I may get a different value of y. And so this is a function. And therefore, we would show the solution to the function, in graphical form. So when we draw a graph on here, it will represent all of the points on that curve, will represent all of the possible combinations that would prove this true. Okay? Now, in order to draw, or in order to sketch the graph of a quadratic, now all quadratics take the shape of what is called a parabola, kind of a U shape. Some of them look like this, and some of them look like this. Now, a quadratic, a second power polynomial, will turn upward if it starts off with a positive, and it'll curve downward if it starts off with a negative. So if we have if we have y equals positive 3x squared plus 8x minus 9, wherever this is on the graph, who knows right now, but we know that it's going to turn upward. But if it was y equals negative 3x squared plus 8x minus 9, then it's going to turn downward. Okay? So up like a cup or down like a frown, okay, are your choices. Now, so you have to understand that when you're going to draw it, but there are four main features of a quadratic graph, and if you're able to identify these four features of a quadratic graph, then you are able to easily sketch the quadratic. So here's what I'm going to do. In this video, just in this video, we're not actually going to sketch the quadratic yet. What we're going to do is I'm just simply going to identify, I'm going to show you how to identify each one of these four qualities, these four features of a quadratic graph. Now the axis of symmetry, because the parabola of a quadratic is a U, it's actually a perfectly shaped U, and it is a mirror image U, meaning that there is basically a mirror that runs right down the middle of the graph. And every point over here is equally spaced, so the distance from here to here is equal to the distance from here to here. Okay? That means that the graph is symmetrical. Okay? It is, so it's equal on the right side as it is on the left side of the graph. And so that makes this middle line, we call that the axis of symmetry. And the axis of symmetry is actually really easy to find it's an x value. See, it's a vertical line, right? Well, at least when we have y equals x squared, then it's a vertical line. At another time, we'll talk about sideways parabolas, but those aren't functions. So what we're talking about right now are the parabola functions. And so the axis of symmetry is a vertical line. Well, how do we define a vertical line? A vertical line is defined as x equals. Like if we go right here, here's our coordinate plane. Here's the origin, 0, 0. If we go over 1, 2, 3, if we go to this line right here where x is equal to 3, well here, this is x equals 3, y equals 1. So this is 3, 1, 3, 2, 3, 3. In fact, let's write them in. This point right here, that's, excuse me, I made the parenthesis the wrong direction. Sorry. That's 3, 1. This is 3, 2. This is 3, 3. Okay, this point is 3, 4. This one down here is 3, -1. This one is 3, 0. Notice how at every single one of these, x is equal to 3. Well, that's because along this line, every single one of these, along this line, every x value is 3. So that vertical line is called the x equals 3 line. That's a vertical line. If I were to ask you, hey, where is the... If I were to say to you, hey, where is the line x equals -7? Well, the line x equals -7, what we would do is we would go to the origin and we would go to where x is equal to -7. So that's left. -1, -2, -3, -4, -5, -6, -7. And so then this line right here, this vertical line, is the line x equals -7. Okay? So we define vertical lines as x equals. It may make sense then to you to know that we define horizontal lines by y equals a number. So this line right here, this is at -1, -2, -3, -4. This is the line y equals -4. It's a horizontal line. Okay? So the axis of symmetry, which is a vertical line, this is a vertical line, is defined by an x value. We just say x equals. And the way you get that is you calculate x equals -b over 2a. Now, when I use these letters a and b, they're the same letters a and b from the quadratic formula. In the quadratic formula, if we were to use the quadratic formula to solve this, and we would if this was equal to 0, if we set this equal to 0, one way we could solve that is by using the quadratic formula. The coefficient of the x squared is given letter a. The coefficient of the middle term x is called letter b. And then the constant at the end is called c. So in this case, a is 2, b is -8, and c is +6. So if the axis of symmetry is at x equals -b over 2a, then in this particular problem up here, we would say x is equal to negative, what's b? b is -8. So it's -8 over 2 times, well, what's a in this case? A is 2. So 2 times 2. And so -8, well, that's 8. 2 times 2, that's 4. And 8 divided by 4 is 2. And so in this case, the axis of symmetry is at x equals 2. And so what we would do then is we would draw a vertical line, and we usually dash it. We usually make it a dashed line. A dashed line at x equals 2, and that is the axis of symmetry at x equals 2. So this particular quadratic has an axis of symmetry at x equals 2. Okay? So how do we identify the vertex? Well, the vertex of a parabola is actually the place where the parabola changes direction. See down here at the bottom of the U? It's right there. If it was an upside down U, it would be at the top right there. That's called the vertex of the quadratic. Okay, it is the place where the curve changes direction. You'll notice that this curve all the way up to the vertex is going down. but after the vertex, it's now going up, okay? So the vertex is the place where the quadratic changes direction, okay? And you'll note that the vertex is actually along the axis of symmetry. It is the place where the quadratic function crosses over the axis of symmetry. So that's a point. It's going to have, this vertex is a point. It has an x and a y coordinate, okay? So when we're going to identify the vertex is identified as an x comma y ordered pair, okay? Now we already know what the x is because the vertex is on the axis of symmetry, it's on the axis of symmetry, then the x coordinate of the vertex is the x value of the axis of symmetry. So in this particular case, the vertex is at the point 2 comma something. We don't know what the other value is. So the way that you find the other value is you plug the 2. You plug that axis of symmetry number, x, into the x in the function. So what we're going to do here is we're going to have y is going to be equal to, well, let me use this. Let me do it right here. Y is going to be equal to 2 times 2 squared minus 8 times 2 plus 6. Well, 2 squared is 4. 4 times 2 is 8. 8 times 2 is 16. So this is 8 minus 16. 8 minus 16 is negative 8. Then we add 6 back, and it's going to be equal to negative 2. And so the vertex of this quadratic is at 2, negative 2. And that's how you identify the vertex of a quadratic. All right, the y-intercept. This one is really easy. Assuming the function is in standard form, okay? Hang on, let me put that back. Assuming that the function is in standard form, the y-intercept is always at 0, comma, c. And when I say c, I'm referring to the letters a, b, and c, like from the quadratic formula. So, in this particular case, where is the y-intercept? Well, the y-intercept, 0, c. In this case, c is positive 6, so the y-intercept is at 0, 6. That's the y-intercept. So, by the way, let me go ahead and mark here. The vertex, right? The vertex is at 2 and negative 2. So we're going to go over to 1, 2. Let me come to this side. 1, 2, and negative 2. 1, 2. So this point right here, that is the vertex of this particular parabola. The y-intercept is at 0, 6. Well, here's 0, and then 1, 2, 3, 4, 5, 6, right there. There is the y-intercept. Okay? So this parabola is going to pass through this y-intercept and then go down and go through this vertex. Okay? Now, I do want to point out, remember what I said about symmetry, about the parabola being symmetrical? That the left side, if there's a point over here, it's the same distance from that point to the axis of symmetry as it is from the axis of symmetry over to the other side. So here's what I want you to learn how to do. After you identify where the y-intercept is, count over to the axis of symmetry. So from here it's 1, 2, and then count that same distance the other side of the axis of symmetry. 1, 2, and put another dot. Because the parabola is going to go through that point also. See, the parabola is symmetrical, so if it goes through the point 0, 6, then it's going to go through the point at a height of 6 as a mirror image on the other side of the axis of symmetry. Okay? All right. We only have one thing left to do, and that is the x-intercepts. Now, I need to warn you that the x-intercepts are the hardest part of the graph of a quadratic. But here's the thing. You already know how to solve a quadratic equation. That's what we did in our last set of lessons, is we identified how to solve a quadratic equation. Well, to identify the x-intercepts, basically what you do is you take your function, leave the y off. Don't use the y. Just take the expression from the function, 2x squared minus 8x plus 6, and set it equal to 0. Set the function equal to 0 because that's because we're setting y equal to 0. The reason we want y to be equal to 0, the x-intercepts are along the x-axis. It's where the graph crosses over the x-axis. And where the x-axis is, well, what's the y value? Well, down here is y equals -1. Up here is y equals +1. So what must this be? This must be y equals 0. So when y is equal to 0, whatever x values we have, those are going to be the intercepts. That's going to be where the graph crosses over the x-axis. So we set the function equal to 0, and now we're going to use one of our techniques, either factoring or extracting square roots or completing the square or the quadratic formula. We're going to use one of those techniques to solve. Now here, this is factorable, so I'm going to factor. The first thing I'm going to do is I'm going to take out a greatest common factor. And the greatest common factor in here is 2. So I'm going to factor out a 2, and I'll have x squared minus 4x plus 3 equals 0. Now, because this 2 out here, because it does not have an x with it, it can't be equal to 0. It can't be the reason that this is turning into 0. The 0 must be coming from inside of here. So we're not really going to do anything with the 2 at all. We just want to factor the x squared minus 4x plus 3. Are there two numbers that multiply to +3 but add up to -4? There sure are. How about -3 and -1? Okay? -3 plus, or times -3, excuse me, -3 times -1 is equal to +3. -3 plus -1 is equal to -4. So this is going to factor 2. I'm going to bring down the 2. Then it's going to become x minus 3 and x minus 1 equals 0. And now how do we solve it from here? We set each one of the factors equal to 0 and solve. So we're going to take x minus 3. Oh, I don't need the parentheses. Sorry. I'll take my x minus 3, set it equal to 0. I'll take my x minus 1, set it equal to 0, and solve. I'm going to add 3 to both sides, and x is equal to 3. Add 1 to both sides here, and x is equal to 1. And so I have two x-intercepts because I have two solutions. If you have two solutions, that means there's two x-intercepts. If you have one solution, that means there's one x-intercept. And if you have 0 solutions, then you would have 0 x-intercepts. Okay? But in this case, I have two solutions. So this solution, it's always that number, so the 3, comma, and then a 0, because it's x comma y, right? X comma y. And what did we make y equal? We made y equal 0. So y is 0. And x is 3. Over here, it's going to be 1, 0. Well, where is the point 1, 0 on the coordinate plane? 1, 0. 1, and not up or down, 1, 0. That's right here. So that must be our x-intercept. And the other one is 3, 0. Okay, so we're going to go over here, and we're going to go 1, 2, 3, that's n 0. So 3, 0, that's our other x-intercept. And notice something. Notice that these 2 points are equidistant from the axis of symmetry. That will always happen. That will always happen. The two x-intercepts will always straddle either side of the axis of symmetry. So if the axis of symmetry is here and and one of your intercepts is 1 unit away on the left, then the other one must be 1 unit away on the right. Okay? Well, that's it.